two identical charged spheres suspended from a common point by two massless string of lengths 1 are initially at a distance d is less than equal to L. Okay. Apart from their mutual repulsions, the charges begin to leak from both the spheres at a constant rate. As a result, the sphere approaches each other with a velocity v. Then v varies as a function of the distance x between the sphere as. Okay. Then here we know that the equation can be expressed as, that is t cos theta is equal to mg. T cos theta is equal to m into g. Then t sin theta is equal to k q square divided by x square. Combining these equations, we get tan theta is equal to k q square divided by x square mg. Then, given that theta is very small, we approximate a tan theta is equal to, that is tan theta as, we can write it as sin theta is equal to x divided by 2L. Then this leads the relationship is x divided by 2L is equal to kq square divided by x square mg. Then solving for the q square is equal to x cube into mg divided by 2 times Lk, or we can say is directly proportional to x to the power of 3 by 2. Therefore, by differential equation, dq by dt is directly proportional to 3 by 2 under root of x dx by dt. Then, which is equal to, we can write it as 3 by 2 times under root of x into v dx by dt. That means the distance upon the time, we can take that one as the velocity. Then we can write that one as under root of x into v. Then since the dq by dt is equal to constant, this implies v is directly proportional to 1 upon under root of x here. So we can say v is directly proportional to x to the power by 2. That means option C is the right answer.